Hello, year sevens. I hope that you are well. In today's lesson, we are going to be learning about circuit symbols in an electrical circuit. Please ensure that you're in a quiet place away from all distractions and that you're fully equipped to begin the lesson. Your first task today is to look at the images and to work out what carrier they represent. Your extension is to consider what these carriers all have in common. Please pause the video and do this now. So the first one is an example of a domestic engineer. These are the people that come to our homes and wire our homes or check electrical faults. The second one is an industrial engineer, someone that works in places like factories and power plants. And these guys can get very, very technical, and it's good to see a lady in that capacity. The third one is a power plant operator. And below we've got a robotics engineer, a mechanical engineer, and a highway engineer. What do they all have in common? They need to be specialists in electricity. I hope you got it right. So our success criteria is to recognize electrical circuit symbols, understand the circuit diagram, and know the difference between conductors and insulators. So, what is the source of energy in a circuit? Mains electricity is often used to power electric circuits. When mains electricity is unsuitable, cells or batteries can be used as the store of chemical energy. This remote control uses batteries. Circuit symbol for cell looks like this. Okay, the longer line shows the positive terminal and the shorter line shows the negative terminal. Two or more are known as a battery, and this is the symbol for battery. So, why do we want to use circuits? Circuits help us to simplify things. If we were to try to draw these wires, it could get messy very easily. So instead of having to draw the diagram, we use representations or symbols. So this is the symbol for the lamp, and that's the symbol for the cell, as we've already discussed. So we don't want to spend lots and lots of time creating very artistic drawings of circuits. We use standard symbols that are much simpler, easier to draw, and easier to interpret. Please pause the video and have a go. Some of this would be recalling information from primary school. Have a go at seeing which of these symbols you can actually recognize. The answers are in the blue writing below. Okay, so the first one is an example of a bulb, okay, or a lamp, a filament lamp. Yeah, this is a circle with an X in it, and there are lines, two lines protruding on either side. We've got an open switch. When the switch is open, electricity is unable to flow. We've got a closed switch. When the switch is closed, there is no interruption, and so electricity can flow. We've got a cell that we've already talked about. We've got battery, and we've also got M for motor. So the longer, so we also have the symbol for motor. In an electrical circuit, you may need to do an investigation, but energy is never lost. It is turned into either motion or heat. In the case of a motor, the electricity travels through coils of wires to generate what's known as a magnetic field. You'll be learning about that in more detail as you progress through the academic years. So we have got these images of symbols. Some of them you should be able to recognize, but there are a few on there that we've not discussed as yet. Can you identify those symbols and have a guess as to what they could mean? Right, so we've not yet talked about voltmeter, the ammeter, and the variable resistor. The variable resistor is used to control voltage or current. Yeah, we have not yet talked about the voltmeter. The voltmeter is used to measure potential difference, and the ammeter is used to measure current, and that is represented by an A with protruding lines on either side. So let's see how well you've been listening. What is the role of the ammeter? And what is the role of the voltmeter? What is a switch? There are sentence starters to get you going. Please pause the video and have a go at doing these now. So the ammeter measures current, the voltmeter measures potential difference. A switch breaks or reconnects a circuit. Okay, if more cells are added, filament lamp will become brighter. Now, we've got a bulb here. Why is the bulb on? Because it's a complete circuit, no breakage. Why is this bulb not on? Because there's no battery. And why is this bulb not on? Because it's an incomplete circuit. How about this example? Which circuit diagram shows this circuit? Is it 1, 2, 3, or 4? The answer would be right. So, can you spot the difference between this diagram on the left and the diagram on the right? That one is a freebie. A wire was placed between the cell and the bulb in order to complete the circuit. Along here, there's no wire here, so the circuit is incomplete, and the circuit is complete on this one. Now have a go at doing the next one for yourself. Let's see how you got on. You had to close the switch in order to complete the circuit. In this diagram, the switch is open. In this diagram, the switch is closed. What about this one? A cell was needed in the circuit. If you notice, in this diagram, there is no cell, and in this diagram, there is a cell. How about this one? Can you spot the difference? That's right. In this diagram, there was no bulb. In this diagram, the bulb's been placed in order for the circuit to be complete. How about this one? Well done. You needed to close the switch. The switch is open here and it's closed here in order to complete the circuit, and added a cell to light the bulb. There was no cell in this one, but we have got a cell here. So we needed a cell in order to light the bulb and to start the motor. Fantastic. So, what are conductors and insulators? In some materials, the electric charges are not free to move. This means the current cannot flow. So conductors are materials that allow the flow of electric charge. Metals are good conductors. Insulators are materials that do not allow the flow of electric charge. Plastic is an example of a good insulator. So, how do metals conduct electricity? It is the delocalized electrons involved in metallic bonding that allow metals to conduct electricity. The delocalized electrons are free to flow through the metal and so carry a current. Insulating materials do not contain free electrons, and so current is unable to flow. Ionic solutions are also able to conduct electricity because they have mobile charge carrying particles. So we've got examples of delocalized electrons here. So, why do cables have plastic coatings? Electricity and electric wires can be very dangerous. Insulators can be used to make wires safer. Metals, usually copper, are used to make electrical wires because they conduct current. To prevent electric shocks, metal wires are coated with a thick layer of plastic. And how does this increase our safety? Plastic is an insulator and does not conduct current. Fantastic effort, year sevens. Now have a go at doing this independently. So we've got a circuit here, like one of the ones that we've looked at, and there is the circuit diagram. So we've got our two lamps and we've got our battery. So why not have a go at actually having a go at drawing the circuit diagram for A, B, and C as an independent activity to do in your own time. Well done. Give yourselves a pat on the back. Brilliant listening.